Hello, this is David Roldán Martínez, Head of Digital Office and Business Development at Affinity, and also Associate Researcher at BRAIN, which is the Valencian Research Institute in Artificial Intelligence of Universidad Politécnica de Valencia. Let me share my screen. Okay. Today, we are going to talk about how GenAI is evolving to reach specialized AI agents. Okay, but we are going to focus especially in how AI agents are redefining API integrations. Here you have my contact details, so please feel free of contacting me and reaching me out for anything you need. I will leave my slides after the conference available on my LinkedIn. I will share with my main insights. So stay tuned and follow me. Okay, which is our aim today? Today we are going to talk about how vertical agents or AI agents, agentic AI, it's redefining API-based integrations. So putting a lot of focus and energy on the potential of APIs and agentic AI collaboration. So these are the main topics we are going to explore today. First, we will make a quick trip on which are the traditional challenges when one is facing API integrations. Then we will state clearly what is agentic AI. We will also see which are the types of AI agents we can see, horizontal and the more specialized version, which is vertical. And then I will share with you my insights about how agentic AI is going to shape the future of API integrations. And finally, I will remark some conclusions. Well, let's go with the challenges faced to be faced when one is dealing with API integration. So, but first of all, let me set and define clearly what an API is. An API, as you know, is a contract between a provider and a consumer that sets pristine clear the operations under that control, the data model, which is the input and output. The input is the data you need to provide to the API to perform the operation. The output is the data you can expect from that operations. And also the error handling. The main advantage of an API is that it can decouple provider from consumer implementation. So provider and consumer can evolve and use the technologies they want in an independent manner. This enables to characterize systems, applications, or whatever, so that we can build digital ecosystem by interconnecting or integrating APIs between each other. So given this, which are the main challenges we have to face when dealing with API integration? Well, the persistent challenges for decades have been complexity. Integrating many systems is not an easy task. Broken integrations, I mean, this means that if the APIs are not properly specified, or even in that case, the integrations are not working, and you don't know why, so you have to open a research to see what is the final cause of this broken, and also if the integration is not properly defined and is not properly fine-tuned, the process can be inefficient. So we are going to see 3 examples of integrations, which are data serialization, rate limiting, and error handling. This means, what means data serialization? It means that if you have two different systems, you will have to make a conversion between the data format that in general can be in JSON, XML, protocol buffers, and many other formats. So if one system speaks one language and the other one speaks another language, you will need to put something in the middle that will translate from one format to another format. Then what means rate limiting? Okay, if you have a system that is able to work at a given piece, at a given rate, and another one that it's working at another rate, you will have to balance, because if you don't do that, the faster system will overflow the slower one. So we have to handle that, we have to handle that differences in the API or in the call processing power. So what happens with error handling? Just the same. Even in the case that your API is properly specified and your error handling routine is very well defined, in the other systems, even in this is the same case. I mean, your two systems are properly the error handling strategy of those two systems are properly defined. They may have some differences, so you will need to put something in the middle for translating or to adapt the one error handling strategy to the other one, so that the integration will be able to handle all the errors as much efficient as possible. So, and now let's go in and what is agentic AI. Okay, what is an AI agent? An AI agent is an application, software, systems that attempts to achieve a goal or serving the world and acting upon that world using some tools that the agent has at its disposal. The key characteristics of an AI agent, what make an AI agent to be an AI agent, are autonomy. That means that the AI agents can act on their own and take decisions without needing to decisions and take actions without needing to ask to a human. They are goal oriented. That means that they are specifically focused on specific goals to reach specific objectives, and they are proactive. I mean, they can learn and anticipate what is going to happen in order to take decisions in an autonomous way, as we mentioned. So, which is the general architecture of an AI agent? Well, we have a model which refers to the language model that will be used to centralize the decision making and the operations, that the tasks that the agent is going to process. Then we have also tools that will allow the agent to interact with the external context. They are mainly the most used one are APIs, and then we also have an orchestration layer that describes how everything is coordinated. Okay, then we can take this a step further and talk about AI platforms. But if you see, this is the architecture of an AI platform, which also is known as cognitive architectures. So these are the foundational components that an AI platform has. We can see that is pretty much similar to an agent. As you can see here, we have model orchestration and tools, and here pretty much the same. We also have an orchestration layer, which makes the governance of everything. Memory management, which means I will need to store some information to be shared, that is shared between different agents. I also have an integration layer, which is how the agents are communicating, are exposing and consuming data from outside the agent platform. I also have an agent marketplace, which is a place, a register, a repo of agents, and where agents, it's a kind of marketplace where each agent is perfectly identified and also described, describing which are the tasks that the agent is performing. Okay, here we have a description of the layers I mentioned in the previous picture. We have the reasoning layer. What does is decompose a complex task into simpler ones. The agent marketplace, which is the registry to facilitate the discovery of AI agents and use them. The integration layer, which is supporting the integrations between agents and the rest of the world. The shared memory to store interaction data between agents. The governance layer, which requires focus on privacy, security, and so on, and orchestration layer, which is used to handle complex workflows. So the benefits of cognitive networks are that the automation and efficiency are improved. We also have more information to collect it, so that we can use data from multiple sources, so that the insights and the results of the processing will be better. We also are able to increase flexibility and adaptability, because autonomous agents are able to respond dynamically to the changes in the context, and also the costs and errors are reduced thanks to automation. But this is not comes alone. Okay, in such complex systems, we also have challenges to be faced. That can be summarized in these four. First, security and privacy. Also, data quality and consistency is key. So because you have to put a lot of effort on your data governance and your data architecture, so that quality will be always keep at high level. We also the lack of when you have a distributed system, the lack of standardization puts troubles in interoperability and integration. Remember the examples of integration challenges we mentioned at the beginning of the talk, and also you will have to face ethical considerations when deploying autonomous agents. Okay, then, how many types of agents do we have? In general, we have two types of agents. The horizontal AI agents, that are specialized AI agents, but not too much. They are horizontal, because they can integrate on integration tasks, but they are not fine-tuned to do some very specific task. So at the end, their performance, the performance or the benchmarking is to achieve the execution of the task at an acceptable level of outcomes. Here you have the limitations of AI agents, and then to overcome those limitations, which is mainly that horizontal agents are only focused on providing an a medium or an acceptable results. Vertical agents come to be more specialized and reliable solution to address those challenges, integration challenges we face with horizontal. I mean, horizontal are very general, vertical are more focused in a given integration context. So examples of vertical agents are copilots. So here, copilots are very specialized in a knowledge domain, so that it can be trained to understand industry-specific terminology, regulations, best practices, so that they can guide you and optimize whatever you do with the agent. Are also autonomous agents. They are AI-powered entities that operate in an independent manner to perform very, very, very specific tasks and processes. They are specifically handled to complex to work on complex scenarios and to be able to adapt to dynamic conditions of the environment. And also we have AI commanders, which are AI agents, very sophisticated, that provide that provides a coordination between the entire AI ecosystem. They are also fine-tuned to specifically to specifically a given context. Sorry. So, which is the difference between horizontal AI agents and vertical AI agents? Okay, we can, the differences are summarized in this table. As you can see, our domain knowledge, horizontal are quite general, vertical are deeply specialized in an industry. Integration capabilities, horizontal are 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 not very focused on or cannot give you a high level of customization, but vertical can, and so on. Okay, then what is going to happen? Why is this so important in API integrations? Well, why APIs are so important? Well, we tend to think that everything is simple. Using an LLM is as simple as asking and then getting an answer, right? But that's not true. The reality is this. AI-based systems are very complex. In general, we have many LLMs working and interacting together, and they communicate through an APIs. Also, different databases spread all over all over your enterprise architecture that can also have an API on top of them. So APIs are everywhere. I like to say that AI is not coming alone. AI makes an intensive use of APIs and data. So embracing an AI solution means necessarily also embracing API and data. You have to look at your API architecture and your API governance and do the same with data architecture and data governance. Think that the quality of AI, the results of AI, are as good as the quality of your data. If your data are not fine-tuned, what you get from AI, it won't also optimal. So and also think that data are spread across over your IT universe, and API are the best way of consuming and exposing all of data. It's a good centralization point to access to the data. So then, given this, what can we expect from future? Okay, the first of all would be composable AI, which means that we will have modular AI systems characterized by the APIs that can be able to be connected between each other, and being integrated through the APIs, so that we can build an ecosystem of AI, which is the composable AI system. Thanks to the APIs, we will be able to link AI agents to get a chain of AI agents that will be able to perform complex tasks from very simple chain of simple tasks. Also, in such distributed ecosystem, we will need to be able to observe what is going on, and so that's why agent observability will be a future trend. We will need to monitor what is going on in our AI system and to take the right and the proper governance decisions. Also cross-industry intelligence sharing, what means that thanks to AI agents, we'll be able to share information between different sectors. And finally, personalize AI at a scale, which means that we will be able to fine-tune very in deep AI agents. So, just to remark one thing, that integrating copilots, agents, and AI commanders through APIs, it will foster innovation. To do that, I mean, to rely on APIs, we need to foster standardization. So we will need standards and API to create cross-industry learning and also adaptation, and to apply the patterns from one industry, the patterns and best practices from one industry to another. So I'm seeing a very fun future. So just to remark, conclusions: the future of vertical AI represents a fundamental shift on how organization can operate, compete, because it's the cost of performing complex tasks is decreasing. So that has an impact on the competitive tension between companies. The benefits of AI agents has a great impact in how API integrations will be happening. Remember the challenges to be faced that was translating between data formats, the rate limiting, and also the error handling. Using vertical AI agents, this can be faced automatically, because the agent is able to learn how to do things and to adapt those parameters. So at this point, which are the main points an organization has to focus if it's wanted to embrace an AI solution? Well, I would say 4 points. First, building modular systems that will allow composition and chaining of AI agents. Second, invest in observability. That means being able to monitor what is going on in their solution. Third, encouraging collaboration between industries to foster innovation. And then prioritize scalability and personalization to enhance user engagement. Okay, thank you very much for your attention, and I will be more than happy to answer your questions.